A light is placed on the ground at a distance of 31 feet from the point at which a javelin will be launched straight up into the air. All right, fine. So 31 feet. There's a light right here, and there's a javelin is going to be launched straight up in the air. And so it's going to travel along this vertical line. And eventually it's going to have some position, and we should call that distance, oh, say, h. And we're being asked to determine the rate of change of the angle of elevation. The angle of elevation is this angle right there. We're being asked to compute d theta dt equals. That's what we're being asked to compute. When the javelin is at a height of 28 feet, fine, so h of t star equals 28. For some t star, we don't care what its value is, but for some t star, it's 28. It's not always 28, it's just 28 for a moment. But this last part of that sentence is moving upwards at 2 feet per second. That says that dh dt equals 2. So that means that there's a motion arrow right here, and I know that that's 2. From these two statements right here, I can see that my task then is to relate in step 2, h and theta. So that was step 1 we just completed, was drawing a picture. Step 2, relate theta and h. I think the simplest way to approach this is going to be a tangent operation. We see that the tangent of theta is equal to h over 31. Right, so toa. Toa, tangent is opposite over adjacent. Opposite of the angle is h, and adjacent to the angle is 31. Opposite over adjacent, tangent theta is h over 31. Step 3, differentiate. Where are we going to start? We're going to start with tangent of theta and h over 31, and we're going to apply the ddt differential operator to it. Both sides. The right-hand side's pretty simple. The right-hand side, I just get dh dt over 31. The left-hand side, I've got to use the chain rule on it. The derivative of tangent is secant squared. And then I've got to chain out a d theta dt, because there is a variable name mismatch between those two things, because theta is a function of time. So I've got to chain out that multiplicative derivative on the left-hand side there. Okay. So that was differentiate. And now we want to substitute as our 4th step. So substitute. We're going to come up with values for secant squared of theta, d theta dt, dh dt, and that's it. D theta dt is my goal. I don't know what that is. That's my goal, right? Put that in green, a little green highlighter. That's our goal. Dh dt, that's 2 because we were given it, because the javelin is moving upwards at 2 feet per second. Secant squared theta then is the part that we're going to need to work on. So in order to compute secant squared of theta, we need to compute secant theta, and then we'll take the square of it. Secant of theta is equal to 1 over cosine of theta. And that is going to be, let's see here, so ka adjacent over hypotenuse. So this would be hypotenuse over adjacent. Does that make sense? It's going to be hypotenuse over adjacent because it's 1 over. And I'm using ka SOHCAHTOA adjacent over hypotenuse. So flipping it. Okay, so the adjacent one is 31. I'm going to refer back to my drawing here. I've got my angle. I've got the adjacent leg, 31. And on the hypotenuse there, I've got the hypotenuse, you know, and so we're going to use our friend, you probably guessed it, the Pythagorean theorem to compute this length here. The hypotenuse is going to be the square root of 31 squared plus 28 squared. Ah, we did use our 28. So I'll take that length of that hypotenuse and propagate that down into my formula down here. 31 squared plus 28 squared. And then if I square that, then I have that secant squared is equal to 31 squared plus 28 squared over 31 squared. Okay, so that side work there all leads into that right there. So we'll substitute. So in step 5, we're going to solve. And I'm plugging stuff into this expression right here, okay? I'm plugging stuff into that expression. So secant squared, I'm going to have 31 squared plus 28 squared over 31 squared times d theta dt, that's my unknown, equals dh dt is 2, and then over 31 is remnant. And then I will multiply by the reciprocal so that d theta dt is equal to 2 over 31 times, maybe zoom in here, times 31 squared over 31 squared plus 28 squared. And now let you simplify that expression. I think the tricky part in this problem is working with this secant squared part. I think that's the tricky part of this problem. One thing you might notice about my work is that I could use much bigger pieces of paper than I give myself. You know, like I need something that's like, I need like another like 3 or 4 inches at the bottom of this in order to really have the room that I need. Space management is hard with these problems. They're long problems. There's no getting around that. Yeah, so there's another path to getting the secant squared part that we could do. So let me do another path to secant squared of theta. I could go theta equals arctangent of 28 over 31. And then I could write that secant of theta squared is equal to, you know, like 1 over cosine of arctangent of 28 over 31 squared. So then you could compute the angle with your calculator. You know, like you've got the arctangent button on here. It's second tangent on here, and that'll give you the angle. And then you could just plug that through the cosine function to get the secant squared value. So that's another path to doing this that doesn't involve using the hypotenuse, but involves arctangenting instead. I wanted to do it the hypotenuse way because that's the way that if you look at solutions in Newton, that's the way that they do it. And so I wanted to make sure that I explained those steps. But you're right, there is another way that we could do this using the arctangent to get theta. I hope that I have acted as a good model for how to solve these problems and giving you concrete steps to practice when approaching them. I look forward to helping you. Feel free to ask for help in any way that you need. I've got my student hours. You can book time with me, and you can write me emails. So any way that I can help you is good. There's also the math lab, and they really want to help you too.